Fluke multimeters include a lot of advanced measurement capabilities that can enhance your troubleshooting style. On the Fluke-87.5, in addition to your standard measurements, we also have some more advanced measurements up along the top here. The one we're going to be discussing now is the frequency and duty cycle. So to how to measure frequency, I have a 110 volt signal. I simply hit the Hertz button and now I'm measuring the frequency. As a quick review, what frequency is how fast is this signal moving. And with the sine wave, we have a power company that's generating a circle. And then we take that circle and we send it down to us. If the circle only went in one direction, it wouldn't get anywhere, so it kind of sends this way and this way and this way. So it's cycles per second. In the US, it's 60 Hertz. In the EU, it's 50 Hertz. And if you're working on airlines, it's 400 Hertz. And this is an indication of how fast it's spinning. Now as you get more into working with motor drives, this measurement becomes a little bit more complex because the motor drive takes your normal sine wave and puts it into a pulse width modulated or a PWM signal. A normal multimeter is not going to be able to measure this frequency properly. We added a feature on the Fluke-87.5 and our 1587. If you see next to the AC volts, there's a low pass. By hitting this yellow button, what I've done is I've now converted this into a special measurement mode that will measure this pulse width modulated signal accurately, giving you the frequency. So you can see if the motor is truly at full speed at 60 Hertz, half speed at 30 Hertz, quarter speed at 15 Hertz. So that's a useful addition that we've put into all our new Fluke 87 multimeters with the Hertz and the duty cycle function. If I press this button one more time, I go into duty cycle. What duty cycle is the percent on versus the percent off, and this can help you troubleshoot power quality problems. If I have a good circle that my percent on and my percent off, or low, negative, is going to be equal. It's symmetrical. If I have a bad signal with a lot of harmonics, I will only see 20 to 30% on, and then the indication at 20% on is 80% off. So by simply doing the duty cycle measurement, I can see if the waveform is symmetrical. This is very handy if you're looking at an encoder where you have a square wave. You'd like to see the pulse maybe 25% on, 75% off is a properly set encoder motor. And so this is how you can use the Fluke 87 to measure frequency and duty cycle and actually measure frequency much more accurately on motor drive systems.